Hi friends, welcome to G tutorial. I'm Grishma. Today we can go through some MCQs from basic electrical engineering. If you have not watched part 1, you can go through that. This is the syllabus for basic electrical engineering. Today we will go through the MCQs of AC fundamentals. Before going through the MCQs, we can first discuss some of the prerequisites of AC fundamentals. A sinusoidal signal is represented by y is equal to a sine omega t, where omega is the angular frequency. RMS value of AC is represented by 0.70 times the maximum value of the current or voltage, and average value is given by 0.637 times the maximum value. Form factor of a circuit is a ratio of RMS value to average value. So RMS value is 0.70 times Im and average value is 0.637 times Im. And by solving this, we will get it is 1.1. So for a sinusoidal signal, form factor is 1.11, or it is the ratio of RMS value to average value. Crescent or peak or amplitude factor, it is a ratio of maximum value to RMS value. Maximum value is Im and RMS value is given by Im by root 2. So on cancellation of Im, we will get maximum value by RMS value is root 2 or 1.414. So the crescent or peak or amplitude factor is root 2, or it is the ratio of maximum value to RMS value. Now we can see a fully resistive circuit, that is only the circuit has resistive components present in the circuit. Such a circuit has no phase difference between the voltage signal or the current signal. They are in phase. For a purely resistive circuit, voltage and current are in phase, which is shown by the graph. Now we can see the power triangle or power factor. The power triangle, we are representing different powers. The hypotenuse represents the apparent power, which is given by V into I, and the real or true power is given by Vi cos theta, that is a base. Suppose theta is the angle formed between the hypotenuse and the base, and Vi cos theta, Vi is the hypotenuse, so Vi cos theta will be the base and Vi sin theta will be the opposite side, and Vi sin theta represents the reactive power, and active or real or true power is given by the base, which is Vi cos theta. Now cos theta can be represented as the ratio of true power or real power or active power divided by apparent power. So cos theta means base by hypotenuse. So it is true power by apparent power. True, or we can represent this as simply as R, Z and reactance. Z is the impedance, R is the Z is the impedance, R is the resistance, and X is the reactance. So in an RLC circuit, if this angle is represented by theta, then cos theta is equal to R by Z. That is the base by hypotenuse. Cos theta is base by hypotenuse. So R by Z also gives the power factor. For power triangle, cos theta is equal to true power by apparent power. These two are important formulas for power factor. The unit of power factor is, it is unitless because it is a ratio of power. If power has same unit now, so the unit get cancelled, so it is unitless. And in the case of resistance and impedance, their units are also the same, it is ohm. So power factor is unitless. Now we can see the case of resistive circuit, capacitive circuit and inductive circuit. Resistance is given by V by I. and voltage and current are in phase in a resistive circuit. In a capacitive circuit, the capacitive reactance is given by Xc. Xc is equal to 1 by omega c or 1 by 2 pi Fc. Omega is angular frequency which is given by 2 pi f. So Xc is equal to 1 by omega c or 1 by 2 pi Fc. Here the voltage lags the current by 90 degree. And in an inductive circuit, the inductive reactance XL is equal to omega L or omega is 2 pi F. So XL can be represented as 2 pi FL. Here voltage leads the current by 90 degree. In inductive circuit voltage leads, and in capacitive circuit voltage lags by 90 degree, and in resistive circuit voltage and current are in phase. These are the prerequisites for doing the MCQs of AC fundamentals. Now we can go through the different questions based on AC fundamentals. First question, what is the unit of frequency in an AC circuit? Unit of frequency is hertz. Next question, which of the following is a characteristic of an AC waveform? Changing polarity is the characteristic of an AC waveform. What is the phase difference between voltage and current in a purely resistive AC circuit? We have seen that in a purely resistive AC circuit, voltage and current are in phase. That is, phase difference is 0 degree. Which of the following type of AC circuits has a phase difference between voltage and current? We have seen that in both inductive and capacitive circuits, there is a difference between voltage and current. So both B and C is the answer, inductive and capacitive circuit. In capacitive circuits, voltage lags current, and in inductive circuit, voltage leads current. In a resistive circuit, there is no phase difference between voltage and current. What is the unit of inductive reactance in an AC circuit? Reactance means resistance itself. For capacitive and inductance, we are expressing the resistance as reactance. So its unit is also Ohm. A coil has inductance of 10 millihenry and it is connected to an AC circuit of 50 hertz. What is the inductive reactance of the coil? Here the frequency is given and the inductance is given. The unit of inductance is Henry or millihenry. So inductive reactance, which is XL. XL is equal to omega L or 2 pi FL. Here F is given as 50 hertz and L is given as 10 millihenry. The value of pi is 3.14. So 2 into 3.14 into F. Value of F is 50 into 10 millihenry. So 2 into 50, 100. 100 into 10 millihenry. 1000. So 1000 into millihenry is 10 raised to minus 3 get cancelled. So this gets cancelled. So the remaining value is pi. Pi is 3.14. So this will be the answer. I think you got the answer. XL is equal to 2 pi FL. 2 into 3.14 into 50 into L. L is 10 into 10 raised to minus 3. So 50 into 2 is 100. 100 into 10 is 1000. 1000 means 10 raised to 3. 10 raised to 3 into 10 raised to minus 3. 10 raised to 3 minus 10 raised to 0, that is 1. So 1 into pi. Pi is 3.14. So 3.14 is the inductive reactance of the coil. Next question. What is the unit of capacitive reactance in an AC circuit? The unit of capacity reactance is Ohm. Reactance means resistance or resistance for capacitive or inductive circuit. So its unit is also ohm. For inductive as well as capacitive reactance, the unit is ohm. A capacitor has a capacitance of 10 microfarad and is connected to an AC circuit, AC source of 50 Hz. What is the capacitive reactance of the circuit? Capacitive reactance Xc is given by 1 by omega c. Omega is 1 by 2 pi is equal to 2 pi f. So 1 by 2 pi Fc gives the capacitive reactance, and 2 into 3.14 into F is 50 and C is 10 microfarad. So 2 into 50 is 100. 100 into this 10 microfarad is 10 into 10 raised to minus 6 into pi gives the answer. This is 1 by. Pi is 3.14. So cancelling this and 10 raised to minus 3, then this 10 raised to minus 3 will be remaining. Taking it to numerator, you will get 1000. 1000 by value of pi is 3.14. Let us approximate it to be 3. 1000 by 3 is almost near to 300, 3.33 now. So 1 by 10, 1 by 3 is 3, 10 by 3 is 3.3. So 1000 by 3 is 333 point something. So the answer closer to that is this. So this will be the answer. Capacitive reactance Xc is given by 1 by omega c. Omega is 2 pi f. So 1 by 2 pi f c. Substituting for each of these values. Substituting for pi as 3.14, f 50, c 10 microfarad. 2 into f is 50, 2 into 50 100. 100 into 10 microfarad is 10, that is 1000, into microfarad is 10 raised to minus 6. 1000 means 10 raised to 3, 10 raised to minus 6 plus 3, 10 raised to minus 3, taking it to numerator 1000. 1000 by value of pi is 3.14. Approximate it to 3. 1000 by 3 is 333 point something. We can choose from the option. This is the closer value to that. Next question. Which of the following type of AC circuit has a current that leads the voltage? The answer is capacity circuit. In capacity circuit, voltage lags the current. We studied like that. So the reverse is current leads the voltage. We have studied that voltage lags the current. That is current is leading. In a capacity circuit, current is leading or voltage is lagging. And reverse is the case with inductive circuit. Study one, it will be good. In a capacity circuit, voltage lags the current or current leads. Current leads. That is enough. What is the power factor of an AC circuit that has a resistance of 10 ohm and inductive reactance of 20 ohm? Power factor is given by cos theta for for this triangle. This is the angle theta. Hypotenuse is given by impedance. This is R and this is X. So cos theta is given by R by Z. Here R is 10 and inductive reactance is given by Z is given by R is equal to R by impedance Z is given by root of hypotenuse is equal to root of base square plus altitude square. So root of R square plus X square. X square. R by root of R square plus X square. R is 10. So 10 divided by R square is 10 square 100 plus 20 square is 200. So 10 by 10 divided by root of 100. R square is 100 plus 220 square is 400. So divided by 500. Root of 500 can be expressed as root 5 into root 100. Root 100 is 10. So 10 and this will get cancelled. 1 by root 5 gives the answer. So we have to evaluate what is 1 by root 5. The value of root 5 is closer to root of 4, that is 2. It is greater than 2. Okay, 1 by 2 is 0.5, but the value of root 5 is more than 2, that is 2 point something, nearly, let us say between 2.5, let it be 2.5. Then it is not 2.5, let us take it is slightly more than 2. 1 by 2 is 0.5, so 1 by value more than 2 will be less than, just less than 0.5, so this will be the answer. 0.447 is the answer. I think you are clear with this. Power factor is given by cos theta is equal to r by z. Power factor is given by r by z. R by z is net impedance. From this triangle, hypotenuse is z, which is the net impedance. R is the resistance and x is the capacitive product, sum of capacitive and inductive reactance. So x is the reactance, R is the resistance, Z is the impedance. Impedance Z is hypotenuse is equal to square root of base square plus altitude square. So we can write root of R square plus x square. R is 10 and x is 20. So 10 by 10 square plus 20 square. 10 by 10 square is 100 plus 20 square is 400. So 400 plus 100, 500. 10 by 500. We can split 500 as 5 into 100. Root of 100 is 10. So this 10 and this 10 get cancelled. So our answer will be 1 by root 5. The closest square is 4 to 5. So root of 4 is 2. So root of 5 will be slightly more than 2. If it is 1 by 2, the answer will be 0.5. But 1 by slightly more than 2, the answer will be slightly less than 0.5. So it is 0.447. What is the term for ratio of maximum value of AC waveform to its RMS value? The answer is crescent factor. We have seen before. Crescent factor is the ratio of maximum value of AC to RMS value. And its value is also we have seen. Which of the following types of AC waveform is commonly used in power transmission and distribution? Sine waves are used for power transmission and distribution. This is the next question. A resistor has a resistance of 10 ohm and is connected in series with an inductor which has an inductive reactance of 20 ohm. What is the impedance of the circuit? Here, as we have done before, the impedance Z is given by root of R square plus X square. That is root of R is 10, 100 plus 20 square is 400. That is root of 500. Root of 500 is, we can, as I have told you before, we can split it as root 5 into root 100. Root 100 is 10. So root 5 is slightly greater than 2. So 2 point something will be the answer into 10. Like that the answer, we can calculate, see the options and find the answer. Is slightly greater than 2 into 10, that is 20, slightly greater than 20. So this will be the answer. Next question, which of the following type AC circuit has a current that lags a voltage? The answer is inductive circuit. We have seen before that voltage leads the current in an inductive circuit, so current lags the voltage in an inductive circuit. Next, what is the term for process of converting an AC voltage to DC voltage? Converting AC voltage to DC voltage is rectification. What is the unit of apparent power? The unit of apparent power is volt ampere or kilovolt ampere. Which of the type of AC circuit has a power factor unit? Resistive circuit has a power factor unity. We have seen the triangle. Here theta is, it is impedance, it is a resistance, and here we represent the reactance. Power factor cos theta is equal to R by Z. For a purely resistive circuit, Z is due to the result of resistance only. So we can write R by root of R square plus 0, which is R itself. So R by R, which is equal to 1. So for a purely resistive circuit, the power factor is always unity. What is the term used for ratio of real power to apparent power? It is power factor. Next question. What is the phase difference between voltage and current in a purely capacitive circuit? It is 90 degree. A 10 microfarad capacitor is connected. This question we have come across before, so we can leave this. What is the term for process of reducing the voltage of an AC source? It is step down or step down. Which of the following type of AC transformer is used to increase the voltage of an AC source? Step up transformer is used to increase the voltage of an AC source. What is the unit of power factor? Power factor is unitless or dimensionless. Which of the type of AC circuit has a power factor always leading? It is capacitive circuit. It has always leading power factor. And lagging power factor is inductive circuit. Next question. A 10 kilowatt AC source has a power factor of 0.8. What is the real power delivered to the source, delivered by the source? Power factor cos theta is the ratio of true power or real power to apparent power. Real power to apparent power. Here cos power factor is given as 0.8 and we have to find the real power, and apparent power is given by 10 kilowatt, 10 kilovolt ampere. So 0.8 into 10, which is 8 kilowatt gives the real power delivered to the source. Unit of apparent power is kilowatt ampere and real power's unit is watt, kilowatt. With this we come to the end of today's class. Thank you. If you are having any doubt, you can comment below.